Hello, today we're going to be talking about input and output, that is reading and writing data. This is a very important topic for R because R is designed for data analysis. So all the time you're reading in data, doing analyses on it, and then writing something to a file. So there are several built-in functions for reading data. The main one is called read.table. These functions are titled read dot something. So if I type read here, it'll show me a bunch of them. Probably the most common format you'll work with is CSV, which is a special case of read.table. So let's start with read.table. And you should have, if you have the GitHub downloaded, you should have a directory called datasets. And let's actually look. Let's get our working directory. So getwd will show us where we are. I'm in the video code directory inside of our Git repo, StackComp 2024. And there should be a, let's see, let's do list.files. Actually, let's do setwd up one level, and then down one level into datasets, and then list.files. Of course, you could do that in one step with list.files. There should be a bunch of files here. So let's go back. Let's make sure we're in the right spot. The general rule for which working directory you should be in the working directory that contains the script that you're working on. Okay, so we'll go up and then down into datasets. And I want to read in a file called marathonwomen.csv. It has a header. And the separator between columns is a comma because it's a comma separated file. Let's actually open that file up so you can see it. Okay, here's the file. It's a plain text file. The first row are the names of the columns of the file, and then each row of the data is a marathon performance. So it has their name in different formats, which race they ran, what year, what time they ran, so on and so forth. This was part of a study we did to analyze data to see if these new Nike marathon shoes called the Vaporfly were helping performance. And it turns out they do. They help by about 3 minutes in the marathon. Okay, so that's what the data looks like. So if we do read.table, this will return a data frame. And so we need to write that. We need to assign it to a variable. And this is going off the page. Let me just collapse this a little bit. Okay. And then we can do class dat. That's a data frame. We could do type of dat. It's a list. And head dat will print out the first 6 rows. Okay, so that's our data set, the first 6 rows of the data set, and that's how you read it in with read.table. Now, if you're working with a CSV, there's actually an easier way to do it. I would just say dat equals read.csv. And not give it extra arguments. The reason is read.csv is really what's called a wrapper for read.table, where it sets these 2 arguments and possibly others to be specific for CSV. So for CSV, it expects the header to be there and expects the separator between the columns to be a comma. So if we run this, this works just as well. Head.dat is the same thing. So let's take a quick look at the documentation for read.table. This is where you can find, all the options for the different arguments you can set. One of them that you may use from time to time is, let's see. Skip. So this will tell it to skip. So sometimes data sets have like metadata at the top, and the real data doesn't start until like the 5th line or something like that. So you can use skip to skip them. And then read.csv, you could see by default sep is comma, so we don't have to set that, and header is true. Okay. And I got these in the wrong spot. Let me just move them. Okay. Now there are also tidy alternatives to these things to read in things to be a tibble. So if we do library read R, we can do dat is read_CSV, datasets marathon women.csv. And if we print dat, you can see that now this is a tibble. This is in tibble format. So if you're into tidy, you can read using read_CSV from the read R package. Okay. Now, if we're not going to go through it in this video, but if you want finer grained control of how to read in each line, there are functions called scan and read lines. So go ahead and look at the documentation if you need that. So one of the nice things about R is it has its own built-in data formats that use compression to make the file sizes smaller. So let's look. I have one saved here already. And let's see. Okay, so if we look at the objects available to us, there's one called dat. And I'm going to load in an object that I previously saved. And I just called it mylist.rdata. So this is useful, for example, if you want to save a list, it doesn't really make sense to save it in a text format like CSV. You could save it in something like JSON, but R allows you just to save it kind of directly as an R object and then load it in simply with the load function. So let's run that. And then we can see now there's a second object called mylist. So let's just take a look at that. This is just a silly little list that I created. Or we could do that over here. One thing to remember about the load function is there's no assignment that happens here. So you're adding an object to your workspace, which you can see we ran ls before and after, and we got an extra object called mylist. But there's no assignment that happens over here. So this can make, sometimes it can make your code a little bit hard to read because it's not clear what is happening to the workspace there, to the environment. So it's often helpful to put in a little comment that says loads object called mylist. So this is where comments can be helpful. The R data format can also support loading multiple objects in the same file. So let's do this again. Load. I have one that has multiple objects in it. So if I run this, you can see again, there's no assignment here. But if I run ls to see what objects, now I have obj1, 2, and 3. And these are R objects. These are actually just the list elements. Okay, so that's how our data works. Our data is probably the most popular, most commonly used R proprietary data format. But there is another one called RDS that you may see from time to time. And it works a little bit differently. Okay, so there's a function called info RDS. This is one nice feature. And I have an object already saved. So what info RDS will do is not actually load the object in, but it gives some information about that object. And then you can actually read it in by doing read.RDS. But here's where it works differently from load. You have to actually make an assignment. All right, so let's actually demonstrate this. ls, that's what's available. If I run read.RDS, you could see it actually loaded something, but if we were to run ls again, it didn't assign it to an object. So to make this work, you have to say my list equals, and now it's there. My underscore list is there, and we can look at it. It's the same exact, well, no, it's actually slightly different because there's a different function here. Okay, so the main difference between read.RDS and load is with read.RDS you have to make an assignment. The other main difference is read.RDS only supports one object at a time, which kind of makes sense from how this works. You wouldn't be able to do this and then assign this to multiple objects. R doesn't work that way. Okay, last thing I want to talk about is the fact that R data and RDS use data compression to reduce file sizes. So let's actually look at the files. So we're in data sets, and there's something called Marathon Women. So these two, we didn't read this in, but these two represent the exact same data set. This one is stored as CSV, which is a plain text format, and this one is stored as the R data format. And you can see that this one is about 6 times smaller. The plain text version is about 6 times larger. So if you have big data sets, it's often useful to store it in our data format if you want to save space. Okay, so down below we're going to show how to actually do that. But this part is just about how to input data into R. All right, moving on to output. The easiest way to produce output onto the screen is to just use the print function. So let's see some examples here. So if we say print my list, that prints it to the screen. If you just type my list, we've seen this over and over again. If you just type my list, it also prints it to a screen, to the screen. So what's actually happening here is when you run this line, it's basically just calling print on that thing to print it to the screen. Now this is important to know because the behavior is slightly different when you're inside a loop. So if we do an R loop, and I say my list, so what you might guess would happen is that it would print out that list. Let me make some space here. That it's going to print out this list 3 times because you're executing this thing 3 times. But it actually won't. If you run this loop, nothing actually gets printed out. And the same is true if you're inside a function. So let's print my list. If you're inside a function, 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 if you're inside prints nothing is a function, and I'm going to say my list here, and the function doesn't return anything. So that defines the function. If I call the function, actually, let me first do it this way. If I call the function, it will print out the function's return value, but you notice it's not actually printing the list here. If I assign, then it prints absolutely nothing, which makes sense because it won't print the return value if you do an assignment, as we learned in a prior video. Okay, so let's see how to actually do this. For j in 1 to 3, you would have to say print my list. So I run that, it prints it out 3 times. Yep, 3 times. And if I want my function to print things out, I have to explicitly again say print my list. So when I run this, when I call the function, it executes this line, which prints it to the screen. And then it's also printing out the return value. If I don't want the return value, I could assign it to a variable. But it's still going to print what I told it to print inside the function. Okay. Here's a little quiz for yourself, something to think about. If I redefine prints something, like that, and then I call it, so it's important. So before you run the code, what do you think is going to happen? Is anything going to get printed out here? So think about that for a second. And then try it. And then you can see that something actually does get printed out, even though I haven't explicitly said print and it's inside a function. The reason it's printing something out is because this function actually returns my list. So if I do this, now it doesn't print, but the result is stored here. Now, print is actually a really cool function, and it's an example of a generic function. So if I just type print here, you could see it doesn't really show any source code. That's because it's a generic function. If I do look at the documentation, print prints its argument and returns it invisibly via invisible x. It is a generic function, which means that new printing methods can be easily added for new classes. Okay, so we're going to see how that actually works. And you can see that, so if I do print dot, you can see there's a whole bunch of functions that are called print dot something, print dot data frame, print dot function, so on and so forth. These are things we've seen before. So you can write your own version of print for your custom classes. So let's look at an example here. I'm going to create a function called print.diagmat. I'm just going to write the function, then I explain what's going on. Okay. Now, if you've ever studied programming, you may have come across the concept of object-oriented programming. That means that objects belong to classes, and then, so these are just different categories of types of objects. And each class or category has what are called methods associated with them. And methods are really just functions that belong to the classes. R has object-oriented programming in it. Most people think of R as more of like a functional programming language, but it does have implementations of object-oriented programming. There's 3 different types. There's like S3, which is the most commonly used one and simplest. There's S4, which is a little bit more complicated but stricter. And then there's something even stricter called reference classes, which doesn't get used very often. You do see S3 and S4 used. Okay, so we're going to show you how an S3 object-oriented class works in R. And the example we're going to use is a diagonal matrix. So a diagonal matrix is a matrix with non-zero values on the diagonal and zeros everywhere else. So if you want to store a diagonal matrix as an object, you really only need to keep the diagonal values, and then you know, based on how many there are, you know how big the matrix is, and you know what the non-diagonal values are because they have to be 0. So you can store a diagonal matrix using just its diagonal values, but when you go to print it out, you may want to print out the whole matrix. And that's what we're doing here. So let's actually make let's make an object. I'm going to call it D. And D is just a regular old vector. But the idea here is these are going to be the values on the diagonal of our diagonal matrix. So if I do that and I print D, that gets printed out. What I really want to print out is I'm going to turn it into a diagonal matrix and then print that out. So D is still D, but I'm going to, when I go to print it, I'm going to print it as a matrix. Okay, so the way this works is I define a method, for a print method for the diagmat class, and it's just as easy as this. I just say print.diagmat. There's nothing special here. And then I have to declare that the class of D is diagmat. So if I do this, 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 and then I do this, now it does this. So what happens here? Actually, let me do this first. When you call print on D, since print is a generic function, it looks at the class of D and then selects the appropriate method for printing. So D has class diagmat. Then when you pass it to print, it says I need to look for a function called print.diagmat. There is one here we've just defined. So it just calls this function. All right, so that just works as it is. And note that we haven't changed D. D is not stored as a 10 by 10 matrix. You could see that by doing, if you do D13, it's going to say there's something wrong. Now you might want to write a method. I think you can write class methods for this function. Square bracket is actually a function in R. We're not going to get into that now. But you can do all kinds of things. You can define how matrix multiplication works for different types of objects. But that's getting pretty deep into the weeds. Right now we're just talking about print. Lots of different code in R uses this kind of concept. So there's actually a package called matrix that has a function called diagonal, which creates a diagonal matrix from its argument. And here it has a little bit of a nicer printing. So instead of doing zeros, it just puts a dot for all the 0 values. So maybe you think that looks a little bit. And then it also adds this like little text here. Okay. By the way, if you haven't seen this syntax here, this means I want to, there's a package called matrix, capital matrix, and I want to use a function in that matrix called diagonal. So I do matrix : diagonal, and I can call that function from the matrix package without doing library matrix, that is loading in the entire package. So this can make your code a little safer because you're not loading in all the functions from the matrix package and potentially creating conflicts with functions that you've already defined. Okay. Now it's really important to understand the difference between print and cat. So let's look at an example here. So if I do print, just some song lyrics here. If I do this, this does what you think it should do. This creates a length 1 character vector, and this will print it out right here onto the screen. Now if I instead pass this to cat, it will also print it to the screen, but it does it without all the fanfare of printing out that 1 there, and it leaves off the quotes. So this may look a little bit nicer. By the way, this looks kind of like it looks here. So probably the matrix, the DDI matrix print class is using cat somewhere in there. Okay. Now you can, cat's kind of cool because you can add special characters. So you can, if you want to put an extra line at the end, it'll do that. You can also, if you do that, you can, this actually doesn't do anything different because if it only does 1 line, it automatically prints another line. But if you wanted to do, a sequence of things here, this will interpret this as a new line and then print the rest of it on its own line, like we see here. And you can also, you could put these wherever you like. You could put one at the top here if you want to make more space, and you could maybe put another one at the end, and that will spread things out. Okay. Yeah, it's important to note that cat works differently than print does, especially with respect to these new line characters. So let me just show an example. Okay, so there's my lyrics. If I do print lyrics, it will not respect these new lines. All right, so the most often way you'll see cat use is when you combine it with other functions that create character strings. So one of those that's probably most commonly used is called paste. So I'm going to create some strings here. Joe Montana, great quarterback. We can use paste first, last. So what happens here is paste takes its first argument, which happens to be called first, which is the character string Joe, and its second argument, which happens to be called last, which is the character string Montana, and puts them together in a single R object, which has one element. It's a character vector, but has one element with those two things pasted together. Now, it's really important to understand what's happening on this line. This actually does not, even though something gets printed to the screen, paste itself is not printing to the screen. The reason this is getting printed to the screen is because this is kind of a hanging evaluation here. It's not assigned to anything. So this actually returns this string, and then it just gets printed to the screen because there's no assignment happening. Okay. And then there's different versions of paste. So you can do paste 0. Let's just see what this looks like. This is the same thing, but by default, paste will put a blank space between the two, and paste 0 will not. If you want to force paste 0 to put the space in there, you can do that. So you can do more than two things. So that will do a space between. And then with paste, you can specify, okay, I don't want to do a space. I want to do something different. So if you wanted to print Montana, Joe, you would do it this way. Oops. All right, so what happened here? So I called paste on 3 objects, and it did Montana, space, Joe, space, comma, space. What I need to do is say sep equals, and that will do last separated by space, comma, first. Okay. Now, like I said, paste is actually not printing to the screen. It's just the fact that it's returning something. So most often you'll see paste combined with cat. And here I'm just doing an extra new line. So what happens on this line, this creates that thing. And then cat prints it to the screen using cat, which gets rid of all this stuff and interprets the new line as a new line. It's probably more interesting if I do 2 of them there. All right, so now there's an extra line. Okay, cat is a function, so it actually does return something. So I could do this. So what happens on this line is cat actually, whenever you call cat, it will print to the screen. I'll run it again. But you can make it return its value. Its value is just null. By the way, the return value of print, so let's see, lyrics. The return value is the thing that you're printing. Okay. Now with paste, you can give it vectors. So say I have 3 different Montanas. And then I paste them. It will put them together, you know, that one with that one, that one with that one, that one with that one. And if I assign this to a vector, I can look at each individual one. So it won't put them together all as a single vector. It won't put them all together in a single element. It will put them together in a vector. Paste also does recycling. So because they all have the last name Montana, I can just give a single Montana and say paste. Just to remind you, first is a length 3 vector. I'm redefining last to be a length 1 vector. And if I do paste first last, it knows to recycle the length 1 vector to match the length 3 vector. Again, you can pass this to cat. That will just put them together, one after the other. If you do new lines, so what happens here is that's a length 3 vector, that's a length 1 vector, that's a length 1 vector. If I put them together, it figures out that you want to recycle this 3 times and recycle this 3 times. And then I can pass the whole thing to cat. And it will print them out on its own lines. If you've done any programming in C or C++, you've probably run across the sprintf function. Sprintf is similar to paste, but it gives you a lot more fine-grained control over how to construct your strings. Okay, so let's look at the same example. And this is how it works. You have to give this like kind of weirdly constructed string. So let me just type it out and then I'll show you what it's doing. Okay, so the first argument to sprintf is this weirdly formatted thing. This %s is telling sprintf that you're expecting to pass it a string, that's what the S is for, and then another string. And so what it's going to do is it's going to take this thing and put it here. Take the value in first, which is Joe, add a space, and put the second one here, the value, Montana, and then insert a new line. And then you pass those values here. So if I do this, now it is printing something to the screen. Oh, I didn't run this. Let me do this. Okay, this is simpler. So Joe was first, Montana was second. It took Joe and put it here, did a space, because I put a space here. Took Montana and put it here, and it did new line afterwards. Now, sprintf is similar to paste in that it simply creates the character string. Sprintf itself is not printing to the screen. That's just getting printed incidentally because it returns a string, and if you don't make an assignment, then by default R will print it to the string. Print it to the screen. Now you can take this and modify it. If I want more space between, I just go ahead and put more space between. If you want to control, so if you have strings of different lengths and you want to control how many spaces are assigned for each one, this is really useful if you're making like text data tables for reports or something like that, and you want everything to line up nicely. So if I do this, this means reserve 10 spaces for the first string, reserve 8 spaces for the second one. So let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we'll count this way. 1, 2, 3, 4, 5, 6, 7, 8, plus this extra space that I gave it. If I want to give it more space, I do that. So then here it reserved 2 extra spaces here. Okay, let's actually do, let's do another example. With our 3 Montanas. Now sprintf will do recycling. Let me put this down here. sprintf will do recycling. First is Johanna Tony, last is Montana. If I do this, it makes 3 things. And these work the same. So, and then I can pass this to cat. And this will interpret these new lines. So the first thing it does is it puts it all together in one single object, one element, and then it calls cat on that. So this puts the new lines there. Now if I want to reserve space, this is what I mean. Now I think there's I don't know if I would call this a bug, but the way in RStudio that it prints this out, it like takes away the first space there somehow. So let me count these up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, actually what it does is it adds an extra space here because there's 11 spaces there. I don't know why it does that. If someone knows, let me know in the comments. Now you can do much more complicated things. Let me show you an example. You can combine numbers with strings here. So what I want to write out is something about Joe Montana and his team, San Francisco 49ers. So I'm going to say %s. Actually, let me give you here. So the values are going to be first, last, num, and team. So Joe, which is first. Montana, which is last. 1. Now for integers, you use %d, so 4. Super Bowl titles with the %s, San Francisco 49ers, period, new line. Okay, so that's, and let me make this look nice. It's always a good idea to fix up your code to make it readable for others. So here you can clearly see this is the string we're working with, and then these are the values that go to create the string. So if I do this, oh, I didn't change it back to a single thing. So Hannah Montana did not win 4 Super Bowl titles with the San Francisco 49ers. It was just Joe. So let me change this back to Joe. And that's accurate now. Okay, and then if I call cat on that, so basically I could do something like this. I could say, well, let me just do it this way. Just wrap it in cat. And that will print it out. Let me save this separately. Okay. You can also do decimals or floating point numbers. So here's our decimal, and here's our string. So we're going to do first, last, %, %s, Joe Montana, completed %f% of his passes. Okay. So let's run this. error. So we didn't run %. Okay, now we get an error for this. Let me slide this back over. Error, too few arguments. So what's happening here is there's this extra % here. And so it's like counting up the %, and it's looking for 4 things to pass to it. But I only gave it 3. So the reason is % is like a special character. It's not interpreted as %, the character % in this context. So what we have to do is, the formal term is escape it. And the way you escape % is just do a double %. So if you do a double %, it interprets the entire thing as just the character %. So this should work. Joe Montana completed 62.70000% of his passes. Now, we probably want more control in like how many decimals we print out. So let's see how to do that. And let's get this all on one line. So the way you do that is you tell %f, just like we did like 10s to reserve 10 spaces for the string. We tell it how many we want to reserve total, so 4, and then how many after the decimal point. So if I do this, it will print this out. If I make the 4 bigger, like 8, it will reserve more space. If I make the 4 too small, like say I only want to reserve 1 total space, it doesn't do anything different from reserving 4. Basically, it still prints the whole thing out. It adds the whole thing. So it will default to like the minimum number that you need to print the whole thing. Let me do this. Just so you have these examples. If you want to give more than 1 decimal, you do a 2 there. And that will give 2 decimals here. All right, now we saw above the sprintf uses recycling. If you want to, so let's create this here. Copy this code down. And let's look here. All right, so that's what happens there with sprintf. If you want to take this and put it into a single string because you need to use it for something else, first of all, cat will automatically do that for you. It's putting it into a single string and then interpreting new lines to make new lines. But if you need to save the actual vector, you can use the paste function. And if I just do this, it returns the same thing. But if I want to put these together, there's an argument called collapse. And what I have to do is say, okay, I'm going to put these 3 elements together into a single character element, but how am I going to separate them? So if I do equals that, it puts no space between. If I do a space, it does a space. And then I can give it kind of whatever characters I want here. I could do space, double pipe. That will do that. Okay. So you can manually force this to collapse into a single element. All right. So the first output topic we've covered is how to print things to screen. So this is really useful if you want to generate text reports that look really nice. sprintf gives you really fine-grained control over how things get printed. The other topic that's relevant to output is writing to files. So let's read in our data set again. And I'll use read.csv. Just to remind you what that looks like, we'll do head dat women. There's also a data set for men. If I read that, it's the same thing, but it's the male runners. So what I want to do here is I want to create a single data set that has both men and women in it. But I want to have a column in the data set that tells you what the sex is of each runner. All right, so what I'm going to do, the way I'm going to accomplish that is for both data sets, I'm going to create a new column called sex, and I'm going to assign female. So what's happening here? Dat women is a data frame. Here I'm creating a new column called sex that doesn't exist in the data set, as you can see over here. And I'm assigning the value female to that column. And I'm only giving a single value. So what's going to happen is it's going to recycle female to fill up the column. So if I run this, now there's a sex column that says female. By the way, I could also do it this way. Double bracket sex. That works as well. I'm going to do the same thing for the men. So dat men, I'm going to make it male. And then I'm going to create a new data frame called dat both, where I'm going to use the rbind function. We've seen cbind to put columns together. Rbind puts rows together. So basically, if you think of this as like this is a rectangle, dat women's a rectangle, and dat men is a rectangle. Rbind will make a new rectangle where the top of it is the dat women rectangle and the bottom is the dat men rectangle. So I do dat women, comma, dat men. That will put them together. Now if I do head, dat both, these are females because I put them on top here. If I do tail, dat both, these are the end of this data set are males right here. Because I put the men at the bottom. Okay. Now the next task is to actually write it. And there's a function called write.csv. It's analogous to read.csv. I have to give it the data frame that I want to write and the file name I want to write to. So I'll put in datasets marathon both.csv. All right, so first thing to notice is you're not assigning this to anything. What's going to happen in this line is you're writing to a file that exists on your computer in this position with this file name. So if I run this, I can go into files, and you can see there's a file called marathon both.csv, and I can click on this to view it, and this wrote the file. Make this as big as possible. At the top are the women, and there's now a column called sex, and at the bottom, if we scroll far enough, are the males with a column with the value male in the sex column. Okay, so that wrote the file. Let me close this up. If you want to look at the options, you can for write.csv. Write.csv. There's a bunch of options you can set. Documented here. One of them that I often use is the default value is the default setting is to write row names along with the data set, which doesn't really make a lot of sense for CSV. There's no reason to keep the row names if they're just like the default 1, 2, 3, 4, 5. So let's look at the file again so I can show you what I mean. It writes a kind of as an empty column for the row names and writes 1, 2, 3, 4. That's not very useful. It just kind of takes up space. So you can actually tell it to not do that. So if I run this, and then I look at the file, it will update here. And now there's no row names associated here. It just starts straight off with the name. Okay, so I usually almost always omit the row names by setting row.names equal to false here. Okay. The other thing we looked at when we were looking at inputting data, let me make this look nicer. Are R's kind of proprietary data formats. So we looked at how to read them in, but you can also write them. So let's make a list. And this is precisely the list that we read in. This is how we got it in the first place. I'm just shrinking this a little so it fits. Okay, so there's our list. We can look at it. That's our list. And then we can say, let me put it here. We can say save my list and then give the file name. And then, so it's going to be in the same directory. And you can see that the mylist.r data was just saved. Okay. Now let's see, just make sure this actually worked. So if we do ls, we have a bunch of objects, but there's one called mylist. So let's remove it. Do ls again. There's my underscore list, but my list without the underscore is gone. Let me save the code here. And if I look at this, it's not there, as we just saw. And then we load it back in. Now it's back again, and it's precisely the same list. That's because we saved it. Okay, so that's how to save using R's proprietary format .rdata. Like we said before, you can save multiple objects. I don't really recommend doing this. It's better to just put everything in a list and save it. The reason is you don't want to have a line in your code like this one, which loads in, a bunch of different objects, because it's hard to read the code and kind of keep track of what's going on when you have something like this, because there's nothing in this piece of code which says which objects get loaded. And actually, when you write R packages, there's actually a rule that when you save data for an R package, you can only save a single object. So you're not allowed to save multiple objects, even though it's technically possible. And the object name, like multiple objects.rdata, the object that you save, its name has to match the file name here. So I think that's actually good practice to follow those rules, because you don't want to have a ton of objects getting loaded in. But let's just see how to do it in case you ever need to. So you just list them out, separated by commas, and then give the file name. So actually, let me show you. This is a common error. If I don't do this, and I run this, I get an error. The reason is it's interpreting you as wanting to save 4 objects, the third of which is the character vector there. So you have to say file equals, and now it will save it with that file name. So multiple objects.rdata right there. Okay. Now we also have the other kind of less commonly used, but in a little bit stricter version of R's format is RDS. So with this one, it's stricter in the sense that you can only save a single object, which is, I think, good practice. For whatever reason, people don't use this as much as RData. So the function for saving is called saveRDS. And I'm going to save the same thing. Syntax is exactly the same. But you will specify .rds as the extension. And where is it here? mylist.rdata and mylist.rds are here. Interestingly, RDS uses a little bit less space, 358 bytes versus 370 for the same object. So it uses slightly different compression. Okay, we already looked at this, but let me just reiterate why this is important. So I'm going to read in the marathon data again. Let me put some spaces here. read.csv. Okay, that worked. And I'm going to take this and save it not as a CSV, but as an RData. What I'm trying to show here is this file here is a plain text file. We've looked at it a couple times already. I'm going to read it into R, which turns it into an R data frame. And then I'm going to save it in R's data format, .rdata. So you're actually explicitly saving a data frame. And it won't be saved in plain text, so it's going to apply compression to this. So let's run that. And then we can look at the difference in size. So here's marathonwomen.rdata. Here's marathonwomen.csv. This one is 6 times smaller, roughly, than marathonwomen.rdata. So again, this is how you save it, and this can be really useful for reducing the file size of very large data frames and other types of objects. Now the drawback is if someone else is using Python to analyze the same data, they're going to struggle to read in R data format So it's better to send them the CSV. However, if you're working with other people who are all using R, then this can save space. Okay, that's it for input and output, and we'll see you in the next one.